So my name is Alda, and I'm going to start today to talk about Apple Platform framework development. I did a lot of this past year and a half at Optimizely, which is where I'm working right now. I don't know if you heard of Optimizely, but we are a tech company based in SF, and we provide A/B testing solutions. I'm sure you guys heard of A/B testing when you view two screens of a web or a mobile screen, and you try to see which performs better. And so we have two major products, like a web component, which is meant for marketing and product people, and our experimentation platform, which has a core of our technology in an SDK for mobile, OTT, and server side. Our SDKs are in all flavors: Objective-C, Java, Android, Python, JavaScript, Node, PHP, Ruby, C#. So I was the tech lead for the mobile and OTT SDK team. We built out our SDKs for 4 platforms: iOS, tvOS, Android, and Android TV. And we had a really short development time. We had probably 6 months among 3 engineers to build all this. So I wanted to mostly talk about that experience for this talk. So before Optimizely, I worked at Microsoft, and I built a bunch of iOS apps. Some of the apps I built were Yammer. It's a team collaboration app. I built also a Skype video messaging app called Quick. And at Yammer, I also open source some UI components. So if you guys have questions about iOS app development, you can also talk to me, because I've done a lot of these apps. And before Microsoft and software, I did a lot of hardware. I was at Apple and Intel, and I worked on Bluetooth devices at Apple. And so I have very kind of low-level perspective on all the software I build. And this is really comes in handy when you're building frameworks. Why am I talking about this? I think framework development is not very glamorous, but it's really hard because I struggled a lot, and I didn't know what I was doing for the most part. I rebuilt the framework 2 or 3 times to get it to the right state. And I think a lot of this difficulty is caused because there isn't very much documentation out there for best practices, and also Xcode has a lot of bells and whistles you don't really know about. It's not really well documented. And also, Apple frameworks have a lot of complexity. It's unlike Android frameworks, which run on JVM. There's different slices of an architecture in one binary, so it's not really simple to build an Apple framework. So some of the topics I wanted to go over today is I wanted to go over our framework architecture so that I can explain how I built out our SDK. And I think it's also important to understand how the framework binary looks like in the compiler tool chain. So I'll go over that briefly. I will also talk about some of the steps I went through to build the framework, but mostly the highlights, because there's a lot of details that I can't talk about today. And also, I wanted to go over our workflow and CLI and end-to-end testing strategies. And most importantly, I'm going to go over the lessons we learned so that you can benefit from this too. So this is how a high level how our Optimizely architecture looks like. When we built out the SDKs, we wanted to make things very modular so that users can replace different components, and they can build their framework leaving out certain parts of it to save memory. So the top 2 boxes at the top are our top level frameworks. The Optimizely SDK iOS pulls in all the dependencies. So we have a data file manager, event dispatcher, and user profile service. And I won't go into what they do, but it's important to know that there's all these dependencies. So these 3 modules depend on shared, and shared depends on core. So there's a lot of interdependencies in our framework setup. And so all our SDKs are open source, and we're trying to encourage people to contribute to it and write their own frameworks, replace the existing modules that they want to change. So I wanted to take a look at the Apple binary. So Apple uses a fat binary, and you'll also hear it being called multi-architecture or universal binary. And essentially, it's one big binary with a bunch of different slices of the same code, but built for different devices. And you'll have a table of content, which tells the operating system which architecture it's going to use. And I listed all the architectures that Apple supports right now. There's i386, x86-64. These are for the simulators. And ARMv7, ARMv7S are for the 32-bit architectures, and ARM64 is for the newer devices. So for the most part, you're probably going to be building for ARMv7S and ARM64. And one thing important to note is that if you're using, when you're running the code, these other slices are kind of like useless. They're just taking up space. So this is, so Apple helped optimize this by introducing app thinning. I'm sure you've heard of it, where they when you upload to the store, they'll pull out all the binaries that aren't relevant to the device that you're building for. And so in one fat binary, you're going to have like different architecture slices. So I want to take a look at one slice and see just generally how it looks. Apple uses this thing called mock-O file format. It's essentially, you'll have a header which tells you which CPU you're using, the little Indian, big Indian, like the byte ordering. And also you have a load command, which is a table of content of all the segment and the symbols. And then lastly, you'll have this raw segment data, which is all your raw code and data. Okay, so the compiler toolchain, I wanted to kind of highlight like high level. Apple uses Clang and LLVM. So Clang is the front end component, which pulls in the source code and dumps out this thing called LLVM IR. And this is essentially assembly code. And the back end will take this LLVM IR and it will optimize it for whatever CPU it's building for. And I just wanted to point this out because there's this feature called bitcode that is a bitstream representation of LLVM IR. And Apple needs this in order to app thin your framework. So it's important to have this enabled, especially if you're building a framework, because people don't want to have really big apps or frameworks. So I'm going to step through like how I built this framework. I actually have a tutorial up at our Medium, our Optimizely Engineer Medium site, and that's going to be posted at probably the end of this week. And it has really like detailed instructions and stuff, so you can actually follow it and build your own like framework really easily. And we tested it for iOS Xcode 9 also, and it works fine. And so like the main goal of this tutorial is it's different from a lot of the other tutorials in that there's a lot of interdependent modules, and we have libraries that are being built for different platforms. Okay, so the first step is you create a workspace, and every module will be its own project. So again, in my previous chart, I had all these blocks. So there's iOS, tvOS, core, shared, data file manager, and all these modules. So that's that. And then the second step is to there's these thing called Pilas Files, and every time you create a project, a Pilas file gets created. These contain like generic things like your version number and your names of the framework. And the more projects you have, the more these generic Pilas files you have, and you want to be able to distinguish all of these Pilas files. So I rename all of them. And you have to remember that in the test section, you also have a Pilas file. So yeah, I kind of learned that the hard way when I was trying to look for Pilas files, couldn't find anything, or it was like mixed up. And the third step is you want to set all your target values. There's a base target, which is what you're building against, and usually you want to leave it at the default, which is the latest SDK. And there's a deployment target, and that's the lowest SDK you want to support. And a good rule of thumb for a framework is to support 2 versions before. And even then, that's really generous because a lot of iOS has a really high update rate versus Android. Android lags a bit more. But in general, we support 2 versions before the latest. Fourth step is I create these configurations. So every build, so every configuration will have its own set of build settings. In our team, we have 4 different configurations. A debug, which is for, you're running on simulator and you're on development branch and trying to, build stuff. We have an RC branch, which we use for sort of our bug bashing release candidate. And then we have a beta version, which we release to customers to test out any new features. And lastly, we have a release version, which is the version we use for the general public release. And then you're going to have to set the architectures you want to build for. The 2 things I want to point out are there's architectures and there's valid architectures. So architectures is a subset of valid architectures, and normally I leave it to the default value. So iOS would have ARM v7 and ARM64, and tvOS would have just ARM64. So normally you can just leave it, but just make sure it's set to the right values. And also, like, one thing I struggled with was trying to put the SDK version in a really central place, because in the past we had 2 places where we changed the SDK version, and it got really hard to deploy because you have to change 2 different places, and you forget one, and it kind of screws up everything. So I figured out a way to organize how to do the SDK to set up the SDK versioning. So there's a user-defined setting in your build settings that you can name some variables. So I broke down the SDK versions into different components. So there's a major version, minor version, patch, and suffix. So the major version is something you bump only when you have breaking API changes. Your minor version is for new features that are backwards compatible. And patch versions are only used for updating bugs or whatever. And the suffix is used to determine which configuration you're using, or your debug or release state. And so the user-defined settings allows you to use this variable within your Xcode build settings to reference the SDK version. But you're also going to have to reference it in your code, most likely. We send it with all our results to our backend. So I found a way to do it with a preprocessor macro. So you can set this value to what you created in the user-defined settings. And you can access the in your source code. You can access it just by calling that whatever you define in the preprocessor macro. And this is really useful because you only have to change the version number in one place, and it just reduces the number of errors you the number of errors you will probably encounter. Okay, so I don't know if you remember the previous diagram. There's I have multiple libraries that are shared or built for different platforms, and those are shared among throughout the framework. So for how I did this was I created different targets for a framework. So I'd have an iOS target and tvOS target. So each target represents a platform I want to support. So later on, we're going to probably add macOS and watchOS here. And I tried doing it in one target and setting all the architectures in one target. But it got really, really messy, and I highly don't recommend it. And a good way to name it is to just add a suffix, iOS, tvOS, whatever platform you're supporting. And it's really important to remember there's no hyphen and no underscore, so you have to keep it kind of like a camel case. I kind of learned this the hard way when it wasn't building. And once you created these targets, you want to add all your source code, your source and header files. And there's going to be slight differences. Like for tvOS, there's no core data, so there's going to be slightly different files for persistence. And then last, you're going to set the module map file in the build settings. And the module map file tells it tells the app using your framework what header file it can access. And you can also use project or private level headers inside the module map file. And lastly, you're going to set the product name and product module name. The product name is just what you're going to call your output framework, and your product module name it's used for like creating bridging header files and some other header files. Generally, you want to keep the two values the same. So I set the product module name to be the same as product name. Okay, and then so that's that, and then pretty much once you get through all those steps, you can have a framework. And in your iOS app or whatever, you can call it using these import statements. So I try to share as much code as possible between like different platforms. So I'll probably switch. I usually use like a switch statement to detect what operating system I'm using. Okay, so that's sort of in a nutshell how to build the framework. Again, my tutorial online has a lot more details, and I recommend you guys looking at it if you actually want to start building something. So next I want to talk about our workflow. I think this is helpful for just anyone like working on any technology. So we're using GitHub, and we have 3 main branches we're working on. The master is our main working branch, and we have a release branch with all our stable releases, and they're named 1.1.x, 1.2.x, and normally we cherry pick features from the master onto this release branch, and then all our hotfixes and patches are done in this release branch, and then merged to master. And then we also have a feature branch, which we use to work on all our feature implementation. And I like to name it. I like to name explicitly like who's the name of the person working on it and the feature. So this we actually took this model from a lot of like startup companies, Facebook is using this model too. So it works well for us. And we used to have a lot more branches, like a develop branch, and it just got really like hard to like maintain all these different branches. So this seemed to work out well for us. And then I want to go over our CLI. This is really important because we really value quality at Optimizely, and we don't have any manual testers, so everything has to be automated. All our testing, all our all our quality control is done like manually, or we try to automate everything. So I wanted to show you like what happens after you do a pull request from that feature branch. So that triggers 3 things. We'll have a cover all, which runs code coverage. We'll have a Travis build that does the unit testing, the performance benchmark, and also all the unit tests. And then we'll also have a Jenkins build. This is private, and it will run through the linter, the static code analysis. We'll also measure the SDK size and run our end-to-end testing. And all of these have to pass in order for us to merge our feature branch onto master. Next, I want to go over how we do our end-to-end testing. So we have, so one of the most difficult thing about testing a framework is that you need a really complex app to actually run to embed your framework in. So something with lots of threads running and something complicated so that you can really bang it out. So we've actually struggled with this, but we are using this app called Shopify, and it's actually open source. You just have to purchase a key to actually use it. But we run our SDK in this Shopify app, and we also use this service called appetize.io, and this will run our demo app in a simulator remotely, and we use a Jenkins job to build and upload our apps into this into Appetize. And we wrote all our tests in JavaScript with the Mocha test framework, and we are using the Appium driver to talk to the Appetize app. And all of this all the tests are run in a Docker environment, and we try to test all our APIs. And the good thing about this setup is that it can work on iOS and Android. You have like a generic JavaScript test that can talk to both apps. So you're not writing tests again for Android. Okay, so next I'm going to talk, this is the most important part, so you're going to pay attention. This is like something you should pay attention to. So I'm going to go over the lessons I learned. So the first thing is that your SDK should never ever crash. The main objective as SDK is to be very reliable and like crash proof. Like when your customers come in with like a crash and you're on the stack trace, it's really embarrassing because you have to like fix it or fend for yourself. Like you just want to prevent that as much as you can. And some of the strategies we came up with to help prevent this are all our APIs are wrapped with a try-catch statement. So if any of the APIs crash, we'll at least have a way to catch it before it crashes the app. We also make all our API calls thread safe because a lot of customers are going to probably abuse it and use it in different threads, and like it's going to crash because it's happened to us. And also you have to be very diligent about inspecting your code. Make sure there's no nil insertions, any collections, and watch out for any memory hazards like dangling pointers. And there's a lot of tools and instruments, especially with the Xcode 8 release. There's really good memory tools to analyze like any dangling pointers or like zombies. Okay, the second lesson was, so the top things customers will always ask for are the size of the SDK and the latency of the APIs. You don't want they don't want their app to be bloated with your SDK, and they want to make sure like you're not causing any latency, and they're like, you're not causing them any sort of delays in how their app is running. And you should try to keep these values as small as you can. So for our API latencies, we actually use the unit test to run all our performance benchmark. And for sizes, how do we check it? So there's actually a really cool new feature called Export Archive in Xcode, and you can archive your app. Again, not your app. You can. You need to first embed your SDK in a demo app and then archive it, and then you do this export archive. You provide a Pilas file to specify like what you want to export, and I give an example right here. And your output is this app thinning size report, and it's really useful. It tells you like the compressed and uncompressed sizes, and you can kind of look at it to see like approximately how big your SDK is. It's a little difficult to measure Apple SDKs because again, there's so many different there's different slices of the binary in one fat binary. So you can't just look at that raw data. You have to kind of like see how you only want one slice of it pretty much. Okay, so third important lesson is you want to your framework should be accessible via CocoaPods or Carthage. Those are really important. People generally use those two dependency managers for iOS. And you get bonus points for creating this universal framework that you can just plop into your app. This is generally for less technical customers that don't want to use any dependency managers. But it's sort of hard to build, and it's a lot to maintain. So you should, really think about it. Also, there's Fabric, which is used to be Twitter, now it's Google that bought it, and pretty much it's a platform for distributing frameworks. And there's a lot of other tools around it that you can monitor, like crashes and there's a bunch of tools around it. I don't even know I haven't really used it too much, but it's sort of a good platform too to like distribute your SDK. Okay, the fourth important lesson is try not to depend on any third-party libraries. So one thing different about SDK development is that you're trying to be very low profile and use bare minimum of of everything. You don't want it to take up too much memory. So initially we did have two dependency. We had JSON model and FMDB. And this caused a lot of problems because customers will have their own versions of it, and there's conflicts, and it's better not to use it, or you can pull it into your framework and rename all the files and classes, and that's what we'd end up doing. So we actually wrote a script to kind of parse through all the symbols and rename all the symbols, and you can actually view it in our SDK since it's open source. Another way you can do is also add a LLVM build setting. And here's an example. Okay, so the fifth important lesson is when you do create this universal framework, you have to make sure that all the architecture slices are there. So again, this universal framework is a pre-built framework that can work on any devices, and you don't need CocoaPods or Carthage to build it. You have to you can manually plop it into any application or app. So this isn't like a really ideal situation because you're going to have all this redundancy. But if you do end up building something of the sort, you should make sure all the architecture slices that you spec'd are there. And we do this by using this tool called Lightbow, and you pretty much it pretty much spits out all the architectures in your framework binary. And the sixth lesson we wanted to go over is you always want to enable bitcode, and you want to check that it's enabled. Otherwise, like when your customer incorporates your SDK and uploads the app to the App Store, they're not going to be able to enable bitcode if all the SDKs don't have that enabled. So this is definitely like a must. And this is how we're checking our bitcode. We're using Otool, and pretty much we're grepping for like LLVM. And the output should look something like this. And the seventh thing I want to talk about is, so we built our iOS SDK in Objective-C, but this was like a year and a half ago, and at that point Swift was still kind of changing and there's a lot of fluctuation. So we wanted something stable, but now I think Swift is getting a little bit better, a little bit more stable. So if I were to do it again, I'd probably write it in Swift. So sort of a good option. And the last important lesson we learned was to add really descriptive logs in our SDK. So we actually have different log levels. We have an error, warning, debug, and info log. So we categorize error logs as anything that causes the SDK to not work. Warning logs are, the SDK still works, but there's something kind of weird, something's gonna be off. Debug logs are just for debugging any issues in the future. So just like details about what's happening. Info log is just specifying some event happened. And in our SDK, we can turn on different levels of logs. And again, you should, it's important to have logs that reflect more than errors, because you want to know, the customers will want to know what's happening. I listed some examples of what some of our logs look like. And yeah, so yeah, that's pretty much it. I have some references about what I talked about, and you can always email me at alda@optimizely.com if you have any questions. Yeah, that's pretty much it. If you guys have any questions.
Thank you. On one of the first slides, you had a picture with a list of slices of architectures, and there were two architectures for the simulator. Why do we have this 32-bit simulator?
You don't have. Nowadays, I don't think you need to support 32-bit. If you want to support iPhone 5 and 5C, that'd be good. But I think if you're not planning to support 32-bit, then you probably don't need to build with a 32-bit simulator. Yeah. Do you
mean that simulator of older iPhone works as a 32-bit application?
This is when I say simulator, that's what's the Xcode iOS simulator that you're running locally.
Yeah.
And you're gonna that's different from what's actually on the device.
Yeah.
So you only need i386 if you're planning to support a 32-bit device. Did I answer your question? I'm not clear.
I'm not sure that there are any 32-bit applications on modern macOS.
It's not an application, it's your device that's 32-bit. So if you plan to support iPhone 5 or 5C, then you're going to definitely need to simulate with a 32-bit simulator.
Okay, I understand. And I have another question about documentation. Do you have any automatization of like generating documentation for your framework and having several versions of documentation.
For all the building, how to build the framework?
No. You definitely should have documentation, yeah?
For the SDK?
Yeah.
Yeah. It's all on.
What tools do you use to generate as a documentation?
Oh, okay, yeah. There's Apple Doc.
Okay.
Because we're using Objective-C still, so we have to use Apple Doc. But I think Swift has a newer version, another version of doc generation. And we also actually have like a developer site on Optimizely website that we manually write. So, but Apple Doc we have, and yeah.
Okay, thank you.
Thanks. I want to ask about your clients a little bit, your approach to managing your clients. So, for instance, when you speak that probably if you will in the future write your framework in Swift or to like migrate to new language, right? How would you like do this with your clients? Would your clients have to struggle with handling things with a new SDK totally? How will you give your support? What happened with your automated tests? Like all the job gets lost completely? Or how do you like plan to not lose everything that you have right now?
Like if we were to switch over to Swift, or? Yes,
like thinking like forward.
Well, we actually did. We had a legacy SDK, and that was like sort of like messier and monolithic. And we're trying to transition everyone off of that to our newer SDK. And yeah, it's hard. Like we have to like just. We're still trying to figure that out, I guess, because you can't support both, right? Like you have this legacy stuff and you also have this new stuff to support. So we're slowly like documenting and training users to use our new SDK. So I think the best you can actually do is like have really good documentation and like training for them. And you're just gonna have to, you know, and also if you like, you know, the newer SDK has like better features, then they're gonna naturally gravitate to the newer SDK, right? So it's a challenge, yeah.